Alright, welcome back everybody. In this video we're going to talk about applying rates of change. So we're going to take the things that we understand about rates of change and put them into problem-solving contexts. We're going to look at 3 different examples. Now realize when we talk about applying rates of change, we're going to talk about broad techniques as we work through these problems that you can apply in a variety of different scenarios depending on the information that shows up in the problem. We certainly will not hit every possible kind of problem where we would apply a rate of change, but we're going to hit some of the bigger points, and hopefully you can take these concepts and apply them to other applications as well. So let's look at the first example. Jose is flying a model helicopter. The helicopter starts on the roof of a building that is 15 feet above the ground. Jose makes the helicopter climb at a constant rate. This is how we know we're applying a rate of change. After 8 seconds, the helicopter is 55 feet above the ground. How many feet above the ground will the helicopter be after 20 seconds? Okay, so the first thing we want to do in this problem, if we're going to figure out how many feet above the ground the helicopter is going to be after 20 seconds, the first thing we want to do is we want to find the rate of change, how fast the helicopter is climbing. And we're going to need 2 points in order to do that. And our first point comes to us from this sentence right here. The helicopter starts on the roof of a building that is 15 feet above the ground. So I'm going to write ordered pairs of this form: time, height. So at time 0, the height of the helicopter is 15. Then I'm going to take my this sentence. After 8 seconds, the helicopter is 55 feet above the ground, and write an ordered pair for that. Using these 2 ordered pairs, I can find how fast Jose is making the helicopter climb. I'm going to set up my slope formula, line up the coordinates from each point, and I go ahead and calculate my slope. And Jose is making the helicopter climb 5 feet per second. Okay. Now we want to figure out how many feet above the ground the helicopter is going to be after 20 seconds. There are a couple of different ways we can do this. We can substitute 5 in, multiply it times 20, figure out how much he made it climb total, and then add that to the starting distance. That's probably the easiest way to approach this problem. We could multiply 5 times 12 and add that to how high the helicopter is after 8 seconds, since that 12 more seconds will have elapsed. I'm going to do the first of these. I'm going to take my rate that he's having the helicopter climb and multiply it times 20 seconds. And so the helicopter climbs 100 feet in 20 seconds. It started 15 feet above the ground. So at the end of 20 seconds, the helicopter will be 115 feet off of the ground. All right, next example, a more mathematical one. A line has a slope of 1/3. The line passes through the point 2, 4. The line also passes through the point 11, k. What is the value of k? Now here's how I would do this. I would use my slope formula. And substitute in all the values. We know 1 point, which we can substitute in here, and a second point, which we can substitute in here, and we know the slope, which we can substitute in here. And so I'm going to go ahead and do that, and I get 1/3 equals k, and put 11 in the denominator, and then in the numerator I've got 4, I've got 2. Now I want to simplify a little bit. I'm going to go ahead and do the subtraction that I can do. And now I could, guess and check values for k and see which one makes this reduce to 1/3. Or I can, solve an equation to help me find this. In my opinion, that's the easiest, most straightforward way. I'm going to cross multiply, since I've got this equivalence here. 9 times 1 gives me 9, and 3 times the quantity k minus 4 gives me 3 times the quantity k minus 4. And now I can solve this equation for k. I distribute the 3 through the parentheses. I add 12 to both sides, and I divide both sides by 3. And I get that the missing coordinate is a 7. Okay? All right. On to our last example from this lesson. Jenna is baking cookies. The table below shows the relationship between the number of batches of cookies she bakes and the number of cups of sugar she uses. Based on the relationship in the table, how many more cups of sugar does she use to bake 7 batches of cookies than she uses to bake 3 batches of cookies? So first I want to find the rate of change, and I'm going to pick 2 points from the table to do this. I'll use this one and this one, and go ahead, and when I do this slope calculation, I'm going to convert these mixed numbers into decimals for calculation purposes. So 3½ is 3.5, and 1 3/4 is 1.75. And then I go ahead and calculate, and she uses 1.75 cups per batch, which makes a lot of sense since she used 1.75 cups for the first batch. So since she uses 1.75 cups per batch, she will use a total of 7 times 1.75 cups for 7 batches. So she uses 12.25 cups for 7 batches. And she uses, you can find from the table, she uses 5.25 cups for 3 batches. And we are trying to find how much more she uses for 7 than for 3. And so we'll subtract these 2 numbers. And Jenny uses 7 cups more sugar to bake 7 batches of cookies than she uses to bake 3 batches of cookies. Alright, that's the end of this little video on applying rates of change. See you guys next time. Have a great rest of your day.